So, hello everyone. This is lecture 6th for the STR, the special theory of relativity. In the last lecture, we studied about the Doppler effect in the relativistic case. Okay, so moving forward, we're gonna discuss about the questions related to Doppler effect. But before that, let's study one more topic which was left, that is transformation of momentum and energy from one frame to another. Okay, so it's not hard, it's very easy. So just like what we have to do here, that this is one frame, okay, the rest frame we can say, and there is this particle moving. Okay, so actually we need to find first we get a expression which will give us a expression that makes the calculation easy for the momentum and the energy in terms of this time. Well, if this is our particle and this is moving, then dt naught will be the original time which was measured by the observer on the p particle, and dt time will be the time observed by this observer here. Okay, so if we get the momentum or the energy terms in this time frame, then we can relate from any form of frames, anywhere there is this frame, we can calculate in that frame the momentum and energy, because we will using this time, and this time will be constant in all the frames because this is the original time. So let's see how can we calculate that expression. So the normal formula for momentum, we know that from this perception of this observer, the momentum will be m naught by root 1 minus u square by c square. Let's say this particle is moving with u speed, then this observer will measure this momentum will be this. Okay, and if we resolve this vector into the xyz plane, then we will get px will be this, pi will be this, and pz will be this with the ux, uy, uz. Okay, in the denominator u will be remain same. Okay, the relativistic factor, because this is relativistic mass. Okay, this will the momentum. So, and if we talk about the energy with respect to this frame, the energy will be m naught c square divided by root 1 and u square by c square. Okay, this is just easy thing, we know this. Now if we talk about the time, then the observed time from this observer of this will be, if this is a true value of time, then what will be dt, that is from time dilation formula, dt naught divided by 1 minus u square by c square. Okay, easy. Now let's say what is ux is dx by dt, and let's multiply it with dt naught. Okay, and rearrange it, then dt naught will be here and this dt will be here. Now this term we will take it out, and dt naught by dt from there, dt naught by dt will be root 1 minus u square by c square. So we'll get ux equal to dx by dt naught root 1 minus u square by c square. Now see what we get. We get speed in terms of this time, the real time. This will be same for all frames. What if there is one more frame here, that is s prime, and we need to measure this ux speed? Okay, then ux prime will be, just here will be dx prime and dt naught will remain same, everything will remain same, and this speed will change at which the that s prime frame is moving. Okay, same we can measure the uy, that will be dy by dt naught root minus v square, same uz. Okay, and if we take this equal to m naught c square 1 minus u square by c square, then what will the energy formula, what will be the energy formula? So energy will be dt by dt naught. How we get this? This can be this you can get, so it was like, from here we can see that root 1 minus u square by c square will be dt naught by dt, and just put it here, then it will be dt naught by dt, so dt by dt naught, so equal to m naught c square dt by dt naught. Okay, and here px will be, px from here m naught ux divided by this, so put the value of ux from here, that is this. So this 1 minus u square by square will cancel out, and we will get this formula. Px will be m naught dx by dt naught. Py will be m naught dy by dt naught. Pz equal to m naught dz by dt naught. So see these formulas, these are very important. Well, just how we have the x, y, z and t, and the x, y, z and t vectors. Okay, same we have these energy and the momentum vectors. These are four. So in general we call them the four vectors. Okay, so just like we calculate the coordinates, that's how we calculate these momentum coordinates and the energy. Okay, so what is the application of these formula, how they are helpful, to us? So you can see that here m naught is constant, that is the rest mass, that will be remain same in all the frames. Here dt naught will remain same because it is the original time measured in the moving frame with respect to the that point which is in the moving frame. Okay, so this will be the original time, this will be the rest mass. Now only change thing is dx. So if there we make, let's let me show you here, if we make one more frame here, okay, and that is s prime. So what we and the momentum in this frame is asked of this particle, then what will you do? You will just calculate the dx prime and put it here, then that will give you px prime. So it's easy, very easy. Okay, that's the same, you just calculate the dy prime and put it here, calculate the dz prime, put it here, you will get the px, py, pz. And same here you need just dt, that you can get from the time dilation formula. So it is very easy to calculate once you derive these formulas. Just you need to remember these, just like for x, y, z and t, you have px, py, pz, p and t, e. Okay, so these are called the four vectors. Actually we will discuss about them in detail later. So how will you measure that? The px prime will be this, and e prime will be this, py prime will be this, pz prime will be this. So you can measure in any frame the momentum and the energy of this particle. Okay, and how will you calculate this dx prime? For that you need the Lorentz transformation. So that is x prime equal to x minus vt by root 1 minus v square by c square. From here you can calculate the dx prime. Okay, dx prime by dt, then you will get here dx by dt minus v dt by dt naught, and that will result in this equation, and that momentum, that m naught will be multiplied here. So just calculate dx prime by dt prime and multiply with m naught, you will get this equation, and from here what we just calculated, m naught dx by dt naught, here that was px. So we'll put it here and minus this. Okay, we just calculated, this is from here energy, m naught dt by dt naught will be e by c square. So put it here, and you will get this formula, v by c square e divided by 1 minus v square by c square. So px prime will be this will be our first Lorentz transformation equation for momentum and energy, as we have for the x, y, z and t. Now same we gonna get from the px prime, py prime, pz prime and energy. These are called the Lorentz transformation equation for the momentum and energy vectors. So that was our first equation. For the second equation, y prime will be y, we know that from the Lorentz transformation equations. So py prime will be same, that is m naught dy by dt naught. Same for the z prime, that will be equal to z, and pz prime will be equal to m naught dz by dt naught. Now the fourth Lorentz transformation equation in the time frame will give us for the energy. So we know that t prime is t minus v by c square x root 1 minus v square by c square. Same for the e prime. We know that what is this formula. So here it is. Just calculate from here the dt prime divided by dt. Okay, and put it here, m naught c square multiply with m naught c square. So what you will get, that is dt by dt naught dx by dt naught, and on multiplying with m naught c square, you will get m naught c square dt by dt naught minus m naught c square this, and divide by this. And what is this? This is energy we calculated in the rest frame. that is this. And what is m naught dx by dt naught? That is momentum in the x direction, and c square will cancel out, so it will give us vpx only, and divide, we have a root 1 minus v square by c square. So we can calculate the energy in s prime frame also. That will be given by this formula, E minus vpx divided by root 1 minus v square by c square. This is called our fourth Lorentz transformation equation in the momentum and the energy, four vectors. Now let's see some questions related to these just topics we studied. After that we will take questions for the Doppler. So a particle of rest mass m is moving with velocity v k cap with respect to inertial frame. The energy of the particle as observed by an observer s prime who is moving with uniform velocity u I cap with respect to s. Okay, what is written? That a particle of rest mass m is moving with velocity v k cap. So this particle is moving, so in the k cap direction with respect to inertial frames. So what you will take the vectors for v are, v p will be 0 I cap, 0 j cap, v k cap. Okay, that will the v vectors. Now you have to calculate the energy of the particle by an observer in s prime frame. Now there is one s prime frame which is moving in the I cap direction, in this direction, with speed u with respect to s, moving with respect to s. With respect to s, that frame is moving in this direction. So you need to calculate the energy of this particle with respect to that s prime frame. So you need to calculate actually the e prime. Okay. So if we take the energy of this particle in s frame, that will be mv square by root 1 minus v square by c square. Okay, v is the speed of this particle and m is the rest mass, so it all gives us the relativistic mass, and mv square will give us the energy. Okay, so if you just correct it, let us see here. You know, formula the mc square. Okay, so if we calculate the energy in the s prime frame, that will be given by this expression, we just derived it. E prime is e minus u px, u is the speed at which the frame is moving, divided by root 1 minus u square by c square. Okay, so from here the momentum vectors are given as a particle is moving in the z cap only direction, so it will have zero momentum in xy and v, and the momentum in z cap will be mv by root 1 minus v square by c square. Okay, this will be, and px will be 0 because vx is 0, and py will be 0, and pz will be this, and E is equal to, in the rest frame, mc square by root 1 minus v square by c square. Okay, so from here this 1 upon root 1 minus v square by c square is given, that is gamma v. So we can write the pz is equal to gamma v mv, gamma v mv. Okay, so it will turn to be this, and energy will be, energy is this. So 1 minus root 1 minus v square by c square is defined as gamma v, that was gamma u for u, and gamma v is for v. Okay, so this will be the energy mc square gamma v, and this will be the momentum in the z direction. Okay, k cap, you can write it like k cap or z cap, that doesn't matter. In the s prime frame, the momentum is given by this formula, we just derived it, that is this px minus v by c square e, so we will use that. So px prime can be written as this, px is 0, so this is the speeds, and gamma v mc square. From here this is 1 minus root 1 minus c square by c square can be written as gamma u. This will give us, c square will cancel out, minus gamma v gamma u mu. Okay, it is not asked in this question, I am just telling you just in case it is asked. Here only we need to calculate the E prime, the energy, py prime is equal to py, that is 0, pz prime equal to pz, that is gamma v mv. We just calculated it here, mv. Okay, now the whole magnitude of momentum will be root px prime v py prime pz prime. That will give us the gamma v mv again. So E prime formula is E minus U px divided by 1 minus U square by C square. What is U here? The speed of the S prime frame. So from here, what we will get? What we will get? That is px can be written as, sorry, it's not px here. Well, yes, it is px, and px is 0. We know that. So it will give us E by root 1 minus U square by C square, and E is gamma v gamma v mc square. So just put it here, gamma v mc square divided by this, and 1 upon this is can be written as gamma u. So energy in the S prime frame will be gamma v gamma u mc square. Okay, so this will be the answer. Just to see these steps also. This can be asked in some other question, that how you will change the momentum in the S prime frame. Now there is one more question we can take. In an observer's rest frame, a particle is moving towards the observer with an energy E and momentum P. If C denotes the velocity of light in vacuum, the energy of the particle in another frame moving in the same direction as particle. So what is given here, that this is our rest frame. A particle is moving in this direction towards this frame, S frame, and there is one more frame, that is S prime frame, is also moving in the same direction as the particle. Okay, so it is asked that the energy of the particle in the another frame, that is this moving frame, will be. So how will you calculate? Same formula. You will, for the S prime, you will put the formula E prime, and momentum is in the this direction. So the minus p I cap, you will put it here. In all direction it will be 0. It will only in the I cap direction, and the velocity vector is also in the minus I cap direction. So velocity of particle will be taken as minus v I cap, and momentum will be minus p I cap. Okay, and we will put it in the energy formula. The E minus I dot I will be 1, and minus V minus P, that is speed and the momentum, divided by 1 minus the speed of the frame, that is minus V, that is square, and it will give you this E minus Vp by 1 minus V square by C square. So this will be the answer. Now one more question. For a particle of energy E and momentum P in a frame F, the rapidity y is defined as this. In a frame F prime moving with velocity v is this 0 0 beta c, with respect to F, rapidity y prime will be. So we need to calculate this expression in the y prime frame. Okay, this formulation. So here we will use the law that Einstein's postulated, that all the laws of physics will remain same in all the frames, in the all the inertial frames. Okay, so we will just, what will get the expression for y prime, that will be 1 by 2 log n E prime plus p3 prime c E prime minus p3 prime c. So just that will change to prime, and this will remain same. So what is p3 here? That is just denoting the z direction. Okay, the third component, nothing else. So this is given like this. This is a particle which is moving, sorry, this frame is moving in this direction, in the z cap direction, with the speed beta c, and this some quantity, that is rapidity, is given in F frame. We need to calculate that rapidity in this F prime frame. Okay, so just put the things as it is asked. We need to take the E prime, P3 prime to calculate. So for E prime, that will be E minus V pz. Here it is pz because it is moving in z direction, and 1 minus z can be written as 3 here, that p3, 1 minus v square by c square, and for p3 prime we can write as p3 minus v by c square e. That just we derived these equations. Now use these formulas, just use these formulas in this. Y prime will be 1 by 2 log n natural log E prime plus p3 prime c. Just put the E prime value here and p3 prime value here, and solve it, and you will get this answer. maybe you will get 1 plus beta above, then there will be negative sign here, so you can just exchange. This will be the answer for y prime. You can calculate it, is very easy. Just put these values in this formula, and in the last you will get somewhere this value also, and that will be equal to y, and then you will get this extra piece. Just when you solve, just put v equal to beta c, and you will get the answer. Try to solve it. There is this last thing in the today's lecture, that is, so that this x square plus y square plus z square minus c square t square remains invariant under Lorentz transformation equations. So when we talk about the different frames or the transformations from one dimension to another dimensions, then there is this bridge. So these type of equations are act like a bridge. As you studied or you have seen in the Interstellar, that is some different thing, that in the fifth dimension that that hero was the bridge. They told that we are the bridge. So that's not the case here. So these equations are the bridge which remains the same in all the frames, in whether it is where or it will be remain same in all the transformation equations. Okay, so it is written that this remains invariant. We need to prove that in the Lorentz transformation equation. Okay, so this is the equation, and we need to prove that this will be equal to this x prime plus y prime z prime minus c square t prime square. This will remain same. Okay, so just what we need to do, take this right hand side and put the value of x prime, y prime, z prime and this prime all, and prove it, try to solve it. Let's see what we get. So from x prime we will get x minus vt by 1 minus v square by c square. Whole square will give us, this root will cancel out, and this will give us this square. Y prime will be equal to y, z prime equal to z. From the Lorentz transformation we know that this will give us y prime, y square, z square. Now here t prime will be t minus v by c square x divided by this square will give us this. Okay, now open these squares and take the LCM. So it will give us x square plus v square plus t square minus 2x vt, and this formulation plus y square plus z square. From here 2x vt will cancel out this. Okay, now from here we can take x square common, and it will give us 1 minus v square by c square. From here minus c square t square will take common. This will give us 1 minus v square by c square. Take this common, and it will give us x square minus c square t square, and the 1 minus v square by c square will cancel out the lower part and the upper part. And in the result we will get what, x square minus c square t square plus y square plus z square. That is nothing but our left hand side. So this will remain invariant. This will give us the same values in all the frames. On the means it is invariant in the Lorentz transformation equations. So what is this? What is the role of this equation actually? So we will gonna study about it in the next lecture. That is Minkowski's space. You maybe heard about it. That is 4-dimensional space where we take one more dimension, that is iota ct, and from here we get this equation, because the magnitude of this vector, which is of 4 dimension, will give us under root of square of all the terms, that is x square plus y square plus z square, and square of this will give us minus c square t square. Okay, so this will be used in the Minkowski space, that is 4-dimensional space. We will study about it. Okay, that will be in the next lectures. Okay, till then just see if you didn't then the previous lectures, and if you have any doubt you can put it in the comment section, or you can ask me directly from where anywhere you will get the information about me. So that's it. Tomorrow we will discuss about the questions for the Doppler effect, and then we will start the rotational matrix or the Minkowski space. That will be our last topic actually. Okay, thank you.